Today I'm going to continue with the revision part of the previous class, like what we have done. I think till array we have completed. I'm just starting from the array. What is array? Array is a data structure, linear data structure, which is used to store the data set of values in consecutive memory locations. That is what array with the same data type, right? See here, the linear array was a n numbers, right? Now n is said to be the set of values, n number of values, and the homogeneous data item. Homogeneous data item means the same data type. It has been stored in the continuous memory locations, right? That is said to be the way it has been arranged in the memory. That is why here we had given, right? It starts from the 0th index until n minus 1 index. It will continue. If this is the case, then how to find out the length of the array? So length of the array is nothing but upper bound minus lower bound plus 1. That is said to be what? See here, upper bound is equals to, say suppose, upper bound equals to 9. So 9 minus lower bound equals to 0. So 9 minus 0 plus 1, that it gives what? 10. So 10 elements are there in this array. So this is how you you can find out the number of elements in the array. And next is how to find out the memory address of a particular element in the index, right? So this is the formula to find out the memory address. LOC is nothing but the location, and LA is said to be linear array, and K is said to be the index, and this is equals to, right? See here the continuous memory locations. It starts from 1000, 1001, 1002, 1003, likewise. Say suppose this is K is equals to 101, 2, 3, 4, 5. I want to find out the memory location of this fourth index, right? K is equals to 4, right? So now location of LA of 4 is equals to base address, that is 1000, plus W is nothing but word size. Word size here, if you see the byte size is what? 1 byte. So 1 multiplied by K is what? 4. 0, 1, 2, 3, 4. So K is equals to 4. Minus lower bound is equals to 0. So 4 minus 0, that is 4. 4 into W, that is 1, 4. 4 plus base address 1000, 1000 gives 1004. That is the location of linear array of fourth index. So this is a simple way to find out the formulae of a particular element in the array. Next is traversing. Traversing, as I told you initially, traversing means visiting a particular element in the array. Visiting an element in the array. Let's see here, it starts from the K lower bound. K is equals to lower bound. So starting value will be initialized to the lower bound. Repeat steps 3 and 4 while K is less than upper bound. So starting value, it should be less than the upper bound. That means what element is available. Always please understand this one. LB is less than UB. So most of the students, they do mistake over here. K, instead of K, they will write it as some other variable, or they will change this greater than symbol, right? So K is less than UB. If this condition is true, then continue with this process. Apply process to LA of K. Here, important keyword is what? Process, right? So process means any process you are applying to that particular element, right? So it is just a traversing. I am not going to apply, I'm not going to explain which operation I'm going to do. I'm going to explain what I'm going to do, right? What means what? Traversing, right? We are applying the process to LA of K, linear array of K. Once it is done, set K is equals to K plus 1 to go to the next memory location and again the step 2 will be checked, the condition will be checked, k is less than lb ub or not, right? So this it will be continued till the n elements or n minus 1 locations, right? So next, how the element will be inserted into an array. Say suppose this is set of elements, right? In the set of elements, the element new element you can insert either at the beginning of the array or the end of the array or the mid location, anywhere in between of array, right? So these are the three possibilities, but wherever you wanted to insert an element into an array, we need a location, right? So say suppose here see the algorithm, there are four variables we have used in this algorithm. One is la, and the other one is n, k, and item. La is nothing but linear array, and n is number of elements, and k is equals to the index where you have to insert, where you wanted to insert, that is said to be what, k, and item is said to be the element which you wanted to insert. Item is said to be the element which you wanted to insert into that particular array, right? So now, as I initially told you, when you are writing an algorithm, please write the variables first and the explanations of the variables, then you can start with the algorithm. Now j is equals to n, so the n value, the number of elements you are storing in a variable called j. Repeat steps 3 and 4 while j is equals to k. While j is equals to k means what? When you are reaching the position, when you are reaching the position, right, that particular till that time, right? Which position? The position which you wanted to insert an element. Till that time, what you need to do, set linear array. Linear array ka value you are going to set. What you are setting? Move downward, move downward. La of j plus 1 is equals to la of j. Means the last element you are moving to the next memory location. The last element you are moving to the next memory location. So nth element will be moved into n plus 1th memory location, and then n minus 1 will be moved to nth location. So this it will be continued. That is why repeat step we have done. Repeat steps 3 and 4. So in first step this will be done, and j is equals to, we need to decrement the j value to go to the previous element, right? So set j is equals to j minus 1. Once j is decremented to 1, so it will go to n minus 1th memory location, and that n minus 1th memory location value will be initialized to n with the help of step 3, right? Now this 3 and 4 it will be continued till it reaches the location where you wanted to insert an element, that is j is equals to k. When it is equal, that means what, you are at the stage to insert an element. So la of k, step number 5, la of k is equals to item, the element which you wanted to insert. Once you have inserted, so the array size has been increased by 1, right? Because the new element has come into that particular set. So you need to resize the array. This is again an important step. Reset n is equals to n plus 1. You are increasing the size of the array by 1. Then exit. Now deleting an element in an array. How to delete an element? Deleting is not at all possible from the memory location. You can delete by replacing an element with some other element, or you can delete by replacing the element by 0, right? You cannot, zeros again a value, so you cannot delete a value from the memory location. That is what the simple basic idea, right? So in that case we need to replace some elements, that is said to be deletion, right? So first you need to understand with which memory location you wanted to delete, right? Which memory location element you wanted to delete. So that see the variables, linear array, L is equals to linear array, and n is said to be the number of element, and k is said to be the location where you wanted to delete, the which element you wanted to delete. So deleting an element is nothing but what? Replacing an element with some other value. We cannot delete the element directly from the memory location. So by replacing element is nothing but how we move the last memory location to the next memory location for inserting. Same way, we need to we need to move the values forward, right? We need to shift the elements forward so that we can replace the previous element, but we need to repeat this till the location where you wanted to delete, right? So as I told you, LA is linear array and n is said to be the number of elements and k is said to be the location where you wanted to delete, and item is said to be the element which you wanted to delete. Right. So whatever you have deleted, that it will be stored under the variable called item. So now first initially only we are removing that value, right? It's not removing, we are just storing into another variable, right? So that if you are writing this into a program, so you can convert this algorithm into a program. So you can say the deleted element from the array is this. Otherwise, you will not get the element after completing step 2 and step 3. Repeat for step repeat for j is equals to repeat for j is equals to k to n minus 1. Repeat for step j is equals to k to n minus 1. So we are introducing a new variable called j, and that we are starting from k. K means what? The index which you wanted to delete. From that to n minus 1. So it starts, consider it starts from 0. 0 to k value is equals to 5 and the n value is equals to 10, right? So 5 to 9. So the last 5 elements will be replaced. How we are replacing? See here, LA of j is equals to LA of j plus 1, means the uh, element from j plus first location, it will be replaced to LA of j. So this it will be continued till these number of steps. See, j is equals to k to n minus 1, there will be 5 steps, so 5 times this it will be continued. once this is done Once this is done, right? So we are resizing the array. N is equals to n minus 1. Why? Because we have deleted an element from the array. That is why we are resizing the arrays. Understood? If you have any doubts, yeah, what is your doubt? Unmute yourself and you can ask your doubt.
So this way we can only delete the item that is at the end of the array, right?
Not end of the array. You are, see here, j is equals to k to n minus 1. It starts from the location where you wanted to delete. As I told you, fifth element if you wanted to delete. So j value is equals to 5 now. See the step number 2, la of j is equals to la of j plus 1. So sixth location value you are storing into fifth location. So by storing the sixth location value to fifth location, by default you are removing the element from the fifth location. Understood?
Yes, sir.
Yeah. It's not only the last element, you can delete any element in between also. Any other doubt in insertion also? If you don't have any doubt, then I will continue with the next PPT. Any doubts? Now here we'll go with the continue with the operations of array, that is sorting and searching. So sorting is nothing but what we can arrange the elements in an ascending order or descending order. So in the,
Yes,
there are many sorting techniques are there, but here as per your syllabus you have only bubble sort, right? Let's see how this bubble sort has been done, right? Individually and with an example. See, as we know, in the 11th standard only, we have done this program, binary search and bubble sort things and all, right? So bubble sort, if you see, there will be, say, suppose there will be n elements, right? So n minus 1 phases will be there, and each and every phase n minus 1 comparisons will be there. Understood? If there are n elements, n minus 1 phases will be there, and each and every phase n minus 1 comparisons will be there, right? So with the basic, I'm going to continue with this algorithm. See here, sort data comma n. So yeah, so see here, there are three algorithms I'm going to teach now: bubble sort, binary search, and linear search. Out of this three, definitely one algorithm will come. It will be either for a 4-mark question or a 3-mark question. If it is a 3-mark question, simply algorithm is enough, right? And if it is a 4-mark, you have to explain with a detailed example along with the algorithm, right? Example means don't write any program and just write one or two values, right? If they are asking you to write an algorithm, it should be similar to this. Don't write your own programs or own statements, right? And the example, it should be like this. Fine. Let's see what are the different variables we are using in this sort. One is data, that is set of elements, and n is said to be the number of elements, right? So first step, repeats to step 2 and 3 for k is equals to 1 to n minus 1. So it starts from 1 and it goes till n minus 1. It starts from 1 and it goes till n minus 1. Set ptr equals to 1. So it starts the first pointer as 1, right? Step 2 3, that is repeat while ptr is less than n minus k. Ptr value is what? 1. N value is what? Say suppose n value I'm taking it as 10. So 10 minus k value, it starts from 1. So k value is equals to 1. 10 minus 1, 9. So it starts from 1 PTR. PTR 1 is less than or equals to 9. So this is what I mean to say the phases, right? Each and every phase, as I told you, n minus 1 phases I told you. So these many phases will be considered, right? In first phase, n value here I take an example as 10. Okay, so data of ptr means data of 1. So first element, here the array index, it starts from 1. Don't get confused from 0, it starts from 1. If data of ptr, that is data of 1, first element is greater than data of ptr plus 1, so second element. So first element is greater than second element. I'm going with the ascending order technique, right? First element is greater than the second element. Then interchange both the elements, swap both the elements, right? Means first element is greater than second element, then first element will be shifted to second element, second memory location, and second element value will be shifted to first memory location. This is what interchanging. Then ptr equals to ptr plus 1. So we are going to the next memory location and we are going to compare the next memory location value with the next immediate next. So this is what I mean to say, the with the help of ptr equals to ptr plus 1, I used to say this is said to be the comparisons, right? So here ptr is less than or equals to n minus 1. It's a phase, and one phase, and this a and b is said to be what? Number of comparisons, right? Number of comparisons, like ptr equals to ptr plus 1, so ptr will become 2. 2 is less than or equals to 9, the condition is true, right? So ptr of 2, second memory location value, will be compared with third memory location, right? So this it will continue till n, means data of 9 will be compared with data of 10, right? So now ptr value when it becomes 10, right, this condition will be false, right? ptr equals to ptr is less than n minus k. So now ptr is less than n minus k, what will happen? K value will become 2. So this it will be continued for the second phase, right? So each and every phase will be considered and individually the elements will be compared. Let's see with an example. There are, when we execute this algorithm for the first time, we'll compare zeroth element with the first element. Yes, zeroth index, actually zeroth index was the first index, correct? See this example. There are five elements, starts from 5, 1, 4 to 8. So the first element ptr equals to 1, data of ptr is greater than data of ptr plus 1. This is what the condition I'm saying. Data of ptr is greater than data of ptr plus 1. If this is true, we are interchanging the locations. So 5 is greater than 1. Yeah, the condition is true. So we have to interchange this. So 1 it will come to this location and 5 it will come to this location, right? Now ptr equals to ptr plus 1. So ptr earlier it was 1. Now it comes to second memory location, that is 5. Right now 5 will be compared with 4. Data of ptr, that is data of 2, greater than data of ptr plus 1, data of 3. So 5 is greater than 4. So this condition is true. Again, this will be interchanging. So 4 it will come to this place and 5 it will come to this place. Right. So now PTR equals to 3. So data of PTR, that is data of 3, is greater than data of PTR plus 1, that is 4. So 5 is greater than 4. The condition is true. Again, it will interchange. So 2 it will come to this place and 5 it will come to this place. Now PTR will become 4. So PTR, data of PTR, that is data of 4 is greater than data of 5, right? So 5 is greater than 8. The condition is not true. So it will be there as it is. There is no swapping. And again PTR will increase to 1. So when it comes to that particular place, then that's all about the first phase. So first phase is getting over, right? If you see in the end of the first phase, the last element will be the greatest element or the smallest element. It depends on the ascending order or the descending order technique, right? So when it goes to the second phase, that last element won't be considered. That is what, that is why we are subtracting the k with the n. So to reduce the number of comparisons in the next phase, we are subtracting this k value, right? So second phase, again it starts from ptr equals to 1, right? Sorry, yeah, ptr equals to 1, and then 1, data of 1, that is 1, is greater than data of 1, that is, sorry, data of 1 is greater than data of 2. So 1 is greater than 4, right? The condition is false, so there won't be any swapping. Then ptr value will be incremented to the next position, that is 4. 4 is greater than 2, right? The condition is true, so there will be a swapping happen. So 2 it will come to this value and 4 it will come to this particular memory location, right? So then 4 will be compared with 5, right? And then 5 will be compared with 8, right? So likewise, each and every phase, all the comparisons will be taken place. And if you see in the second phase only, in this particular comparison only, we got the sorted elements. right? So it's not like that once we got the sorted element, it will stop the process. It will continue till the end of the comparisons and end of the phases. So as I told you initially, this type of example you need to write along with the explanation of this algorithm that carries 1 mark, and the entire algorithm you need to write as it is, it's for 3 marks. Then linear search, a searching methodology, right? This linear search and binary search, say suppose linear search, right? This is a textbook, right, which consists of n number of elements. This is said to be now set of elements. So in this set of elements, you are going to search an element, right? You are going to read some content, right? But you don't know which page number it has been arranged or which page number it is available. So what you will do, you will start reading page by page. So once you reaches that particular page or you found the content, so what you will do, you will stop the searching process, right? If you are not getting it continuously, so you will go till the last page, right? So if you are going till the last page and still you are not finding the content, that means what, the particular content is not available in the textbook, right? So there are two possibilities: either the element it can be found or it cannot be found, or it may not be found, right? So with the example, see this algorithm, there are four variables we are using. One is data, as I told you initially, the set of elements, and n is said to be the number of elements, and item is said to be the element which you wanted to find, and loc is nothing but the element is found at which location. The element is found at which location, that is what loc. Right, now insert an element at the end of the data. So the element which you wanted to find, that you are inserting at the end of the set of array, right? Slightly there is a change in the logic, but still the example you can relate it, right? See here, the array is what, 10, 50, 30, 70, 80, 60, 20, 90, and 40. So there are 9 elements. Consider the elements index starts from 1, right? So the element whichever you wanted to find from the set of element, that you are inserting after this memory location, that is ninth index or 10th index, you are storing the element, right? Say suppose if you wanted to find 20, so 20 will be added into this particular place. Now what I'm doing, this 20, I'm starting comparison from this first element till the last element, or till the element where you found. So this is what linear search, right? Sequential you can say, right? So the first step, data of n plus 1 is equals to item, and set loc is equals to 1. So location value you are initializing to 1. This is important step. Repeat while data of location not equals to item. So continue this step. Which step? This particular third step. Continue this step till you have not reached or till you didn't find that element in that array. So data of location value is what? 1. So data of 1 is not equals to item, the element which you wanted to find, right? If it is so, then increase the memory location by 1. So location equals to location plus 1. It will go to the next memory location, right? So this again it will be continued. So location, data of location 2. The data of 2 is not equals to item. If it is not true, then increase the memory location. So this it will be continued till the element found in the memory location, right? Once you found, so location value will be having a value which is the place where you are having or where you are finding that element. Now step number 4, if location is equals to n plus 1. Location ka value when it will become n plus 1, when you didn't find the element. n here n plus 1 is what? N plus 1 is 20, right? When this location value, see, this is what location, it is starting from, it is coming to 0 and it is going to 1 2 3 4 5 likewise. So location value is in the yellow line, wave line, so it is going incremented by 1. When this location value will become n plus 1, if 20 is not found, or if the element is not found, it will by default go into the last memory location. That is what the step number 4. If location is equals to n plus 1, that means what? The element is not found in the set of array. Set location equals to 0. So in that particular time, set the location values equals to 0. Initially, what was the condition? Location equals to 1. At the end, you are making it as 0. Why? This is helpful in the programming to continue, whether you found the element or not, or if you found the element, which memory location you found. Likewise, you can continue in the programming, right? So if you have any doubts, you can ask me till linear search. If you don't have any doubts, then I will ask you questions. Yes, there's no doubts. Okay, so if you don't have any doubts, then join the same meeting after 2 minutes. The meeting is about to over now. Now you can leave and join the same meeting link after 2 minutes. Then we'll continue with binary search. Then we'll discuss with some questions.